All right. What's an isotope? Go ahead. Say it again. Okay, not electrons. Neutrons. So if we define isotope again, an isotope is going to be an atom. It's actually going to be at least two atoms because we're talking about isotopes of each other. So if we have two different isotopes, they're going to have the same number of protons and they're going to have different number of neutrons. Can I fit this in here? Okay. Now keep in mind that when we say this and we talk about the number of protons, we can also say that they have the same atomic number. And when we say they have different number of neutrons, we can say that they have different mass numbers. Okay, so there's some vocabulary that's coming down the pike here. Yesterday we talked about the vocabulary of what an atom was. Now we have isotopes of those atoms. So we've seen this before. So let's say if we have carbon and it has an atomic number of 6. Okay, those are both atomic numbers. They're the same atomic number. The top numbers, which are the mass numbers, will be different. So these are isotopes of each other. Okay, easy peasy lemon squeezy. Now, remember what this number is. This is a mass number. What is the difference between a mass number and an atomic mass? Go ahead, Dylan. You don't know? Does anybody remember what the difference is between?
Mass number is like for that atom.
Yep.
And atomic mass is the average.
Right. So this atomic mass is an average. And that's what we're going to learn today, how to calculate the average atomic mass. So if I come over here to this one and I pull up my reference tables, see if we can find them. There we are. When you go to your reference tables and you pull up the periodic table, and you're looking at this top number, it's going to be an average. Okay, now, how do they calculate that average? There's not a little scientist in a room somewhere counting atoms. That's not how they do it. Okay, because first of all, atoms are really, 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 really small. So he'd be counting for a long time. And the world is really, 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 really big. So he can't count all of those atoms. So let's keep that in the back of your mind right now, that we're not actually counting the atoms. We're going to take a step back. When you do an average in math class, how do you do it? Add them all up and divide by the amount. Okay? So let's imagine that we could do that with some atoms. So let's say we have carbon 12, carbon 12, carbon 12, carbon 12, carbon 12. That's 5. Let's do 7. Okay. If we have 7 carbon 12s and we have 2 carbon 14s, okay, that's a total of 9. If I wanted to find the average, I would take 12 plus 12 plus 12 plus 12. So somebody with a calculator, because I don't have one in front of me. Actually, I do. Let's see. Let's add them all up. Thank you. 12 plus 12, or 12 times 7, which is 84, plus 14 and 14, which is plus 28. That's going to give me 112 divided by 9. And I get an average of 12.4. That's assuming that a scientist could count individual atoms, right? Can't do that. So we have to come up with a way of getting this 12.4 without adding them all up and dividing by the number. When you calculate average isotopic mass, it is dependent on how many of these you have and what the isotopes are. The percent of that isotope and the percent of this isotope. Okay? So just keep in mind, let's redraw this so that I don't have to copy, paste. Okay. All right. So let's find the percent of carbon 12s that I have and the percent of carbon 14s that I have. How do you find percent? Does anybody know how to find percent? Okay. So when you're finding percent, it's out of 100, right? So it's going to be, the formula for finding percent is going to look like this. The part that you're looking for, you're going to use this formula all year long, okay? The part that you're looking for the percent of. So if this is percent of carbon 12, then this P stands for the number of carbon 12s that we have. So I'm just going to put a carbon 12 down here just so we remember that we're doing the carbon 12. And then the bottom number is going to be whatever you have the total of. And in our case, it's going to be 9. You see that? So I have 7 carbon 12s and 9 as my entire thing. And because it's out of 100, we're going to multiply that by 100. So this is our percent formula. Our percent formula always looks the same. It's going to be percent equals part over whole times 100. All right, so we've got 7 carbon 12s. We've got 9 total, that's the whole, times 100. That's going to give me my percent of carbon 12. Let's do this. 7 divided by 9. 77.7. Did you guys get the same thing? Make sure my math is right, because I sometimes put things in the calculator wrong. Okay, so we've got 77.7% carbon 12s, which means what percent will be my carbon 14? Now there's two ways to do this. 33. No, not 33.3. Just doing math wrong. 66.7 would be 33. Yeah, so 22.3. So, all right, hold that thought for a second. We can do it two ways. We can say we know that we want it to be 100%. So we could take 100% minus the 77.7, and we would get 22.3%. So 22.3% is going to be carbon 14, whereas 77% was carbon 12. Do you understand? Don't try to memorize the process. Understand what's going on. I just found the percent of my carbon 12s, and I found the percent of my carbon 14s. I could have taken my carbon 14s and done percent equals the part that was carbon 14 over the whole times 100. And I would have gotten 2 divided by 9 times 100. And that better be 22.3. Let's check our math. 2 divided by 9, 22.222222222. Okay. 7 divided by 9 was, oh yeah, because this should have been an 8. Okay, look. Can you see that calculator there? 77.77 should have rounded to 77.8. 8. So let me fix that. Make sure we're rounding correctly. This is what I call an ugly number, right? It's a really long number. And then this one would have been 22.2. Okay. So what I want you to understand right now is where they got these percentages from. So what will happen is a scientist will go and will take a piece of carbon and will decide how much of that carbon is carbon-12 and how much of that carbon is carbon-14, percentage-wise, and assume that that's what the whole world is going to be. Okay? So he takes a sample of carbon-12 from a fossil of a woolly mammoth. He takes a sample of, he takes a sample of carbon from a fossilized woolly mammoth. He takes a sample of carbon from a tree that's growing today, and he figures out what the percentages are. Once you get the percentages, hint, hint, you're always going to be given the percentages. Okay? You're going to be given these percentages. Now what he does is he says, all right, I've got 77.8% carbon-12, and I've got 22.2% carbon-14. Now I want to figure out what the average atomic mass is going to be. What do you have more of? Do you have 12 or 14? More of something that weighs 12 or more of something that weighs 14? 12. Because you have more of what weighs 12, your average will be closer to the 12 than it is to the 14. You understand? Allison, you got it? You weren't here yesterday, so. Okay. So, we're going to make sure that our answer is closer to 12 than it is to 14. Okay, this is what we're going to do. We're going to take the percentage, which in this case is 77.8%, and we're going to multiply it by its mass, which is 12. And then we're going to do the same thing for the next one, but we're going to add them together. So 22.2% times 14. And if there was a third isotope, you would do it again. And if there was a fourth, you would do it again. And a fifth, and a sixth, and a seventh. You know what I mean? So no matter how many isotopes you have, you're going to sum the products of the percent times the mass. All right, let's do it. How do you put 77.8 into your 77.8% into your calculators? Yes, you have to change that percent to a decimal. And in order to do that, you can either divide by 100 or move the decimal 2 places to the left. So this becomes 0.778 times 12 and 0.222 times 14. Now stop right there and everybody's eyeballs look up here. This is 99.9% of the time what the Regents is going to ask you to write down. Right here, this. Okay? If it is a short answer question, they will say, show the correct numerical setup, which means they are looking for this. You don't even have to solve it. Okay? We are going to solve it, but the Regents usually will say, show the correct numerical setup for calculating average isotopic mass or average mass. Okay? This is on every single Regents. Every single one. And last year, in June, only 46% of our students got this correct. I don't understand why. Maybe it's because we do it in the first month of school and you forget. Okay? But this is 2 points right here. Just write this down. Okay? If it is a multiple choice question, a lot of times they will write it like this. Sometimes they will do this. They will say 77.8% times 12 plus 22.2. I'm going to run out of room here. times 14. Sometimes they do this. See this? They left the percent sign in here. Okay? Sometimes they do this. 77.8 times 12 plus 22.2 times 14 divided by 100. Sometimes they do that. Those sneaky guys, they do. Okay? Sometimes they do this. 77.8 times 12 divided by 100 plus 22.2 times 14 divided by 100. It's all the same thing. Okay? So don't get confused when you see it as a multiple choice. If the percent sign's there, that means they didn't move the decimal over. If it's not moved over, you have to see if it's divided by 100. So the percent always has to be moved to put it into the calculator. But these are the choices they're going to give you as a multiple choice. I'll pull some up in a few minutes and we'll take a look at them. Let's see. Okay, let's do the math. Let's see if our math comes out right. Let's see if we end up with, what's the average we got? 12.4? Let's see if we get that. Okay, 0.778. I don't know if you can see my calculator there. 0.778 times 12 gives us 9.336 plus, I'll do it in two steps, 0.222 times 14, which is going to give you 3.108. Now we got to add them together. 9.336 plus 3.108, 12.4. If we're going to one decimal place. I don't know if you can see that. Okay. I'm going to show you something else. Let me just move this out of the way so maybe you can see the calculator a little bit better. If you want to do it all on your calculator without doing it in separate steps, this is what you're going to have to do. You're going to have to do 0.778 times 12. Hit enter. Then I'm going to hit plus, which you can't see it because it's over here on the thing, plus parentheses 0.222 times 14, close parentheses, equals. Okay, make sure you're putting these in parentheses. Okay, you don't have to do the first one, but you definitely have to do the second one, or your order of operations is going to be all screwed up. So just make sure. Okay. All right, let's try another one. I'll make another one up, and then we'll go to some on the paper. Okay. Let's say you have 99% hydrogen 1 and 1% hydrogen 3. So I'm not giving you the individual atoms, I'm telling you the percentages. What would it look like if you were to write it out? Okay. So we're going to take 0.99 times what? 1 plus 1%, change that to a decimal, 0.01, you guys are smart, times 3 equals. Now 0.99 times 1, even I can do that in my head. And 0.01 times 3, I can do that in my head too. Okay. And so then I got to add these up. 9 plus 3 is 12. 9, 10, 1.02. Check my math on your calculators just to make sure, because I make mistakes. I don't think I made one this time, but 1.02. And notice that my average is closer to the 1 than it is to the 3, because I've got more hydrogen 1s than I do hydrogen 3s. Okay? All right. Now, I have a worksheet for you, but this worksheet is disgusting. It's horrible. It's a horrible worksheet. I'm gonna give it to you. We're not gonna do all of it. I think it's like 4 pages, and I was even talking to Mr. McGregor about it on the way in this morning, and I'll show you why it's terrible. But hold on a second. Let me stop this video for a second. Okay. Here's our ugly worksheet. Now everybody has a copy of it. It says, what is the average atomic mass? So we know we're calculating average atomic mass of the following isotopic mixtures. Show your work. All right. It tells us you have 22% of 159.3 AMU and 78% of 161.2 atomic mass units AMU. So let's set it up. Let's write it out. We've got 22%, so we're going to change that to a decimal. It's going to be 0.22 times the mass, which in this case is 159.3, plus 78%, which is 0.78 times the mass, 161.2. And they gave us some ugly numbers here. So let's do this. 0.22 times 159.3. And you get 30, I can't read it, 35.046 plus 0.78 times 161.2. I got 125.736. And now I'm going to add them together. And I got 160.782. Check my math.
Yeah.
Okay? Good? All right. I want you to try the next one on your own. They gave you the percentages are here and the masses are written right in front of them. Okay? I'll shut this video off and then we'll come back.